Okay, before we look at this specific problem, let's just look at a simpler example where we're dealing with squares, which all squares are similar. Let's say I have a square with a side length of 3 feet. Then the perimeter of that square is 12 feet. And the area of that square is 9 feet squared, side squared. And let's say there's this constant of proportionality 5 that I'm going to multiply 5 times every side length to get a new bigger square. So that means that each side length will be 15, and the perimeter will be 60, 4 times 15. But we could also have gotten that by taking this constant 5 times the perimeter of the original square. 5 times 12 is 60. So these are linear measurements. That's why we don't square anything. But the area of the new square is 15 times 15, or 225 feet. Or we could have gotten that by realizing that k squared is 25. Now, why would I use k squared? Because this 15 feet is 3 times k, and so is this one. So the area of the new square is 3k times 3k, or 9k squared. So when you're comparing areas, it's the square of the constant of proportionality. Okay, so let's go to your problem. Let's say I have these two figures that are similar. I just kind of drew something that looked like trapezoids. But the constant of proportionality is, in this case, 66.4 divided by 25.6, which is 83/32. If you did this on a calculator, you could get a decimal for this. When we're comparing areas, we square that constant. Again, you could get a decimal approximation. And so if we let a sub 1 equal x as the area of the smaller similar figure, then k squared x will be the area of the larger similar figure. And these two areas, when you add them together, is 712.17 inches squared. So if I want to solve for x, which is the area of the smaller similar figure, I can factor out that x. Here I rewrote 712.17 as 71,727 100ths. But x equals that number divided by k squared plus 1. And here's k squared plus 1. So to solve for x, I would multiply both sides by the reciprocal of k squared plus 1. 1024 over 7913. Okay, and here it is using decimals. Okay, there's the area of the smaller similar figure. There's the area of the larger similar figure, and they do add up to 712.17. There you go. Hope that helped. If you have any questions, post a comment.